In this lesson, we'll talk about networking models, what they represent, what they offer to you, and why it's a good idea to have them. Think of networking models as architectural plans or blueprints like builders use. When you have 5 or 10 or 20 subcontractors working on a building, models and standards are essential to make sure it turns out the way the architect envisioned. Software is the same way. Imagine that you have several different software and hardware vendors. Each of them produces their own applications and hardware. You need some assurance that products from different vendors will work together, even if they aren't made specifically for each other. So vendors follow standards for how their products should operate and communicate with other products. With this concept in mind, let's look at a generic 3-layer model. Each one of these represents a workstation or an end node on the network. Let's call the one on the left you and the one on the right me. On the very bottom of these networking models, you want to consider the physical network where things plug in for network access. So this is where the network nodes physically access the rest of the network. At the very top of this model, there's the network applications that we deal with every day, such as a browser. Through the browser, you make requests to the network. Let's say you want to pull up www.cisco.com. When you type the address into the browser and send the request, the model gets involved. That's when applications or protocols running here, here, and here have to manage that data. In this case, we have 2 nodes on the network, you and me, and I'm providing web services to your network. I'm a web server, and you can pull web pages off of me within your own local company. So when you enter a request to go to Cisco.com, these different layers of the model are going to do things like format your data. They'll put it into a form that computers can recognize, 1s and 0s. They might encrypt your data to secure it because your system knows that to get to Cisco.com, that request has to be sent to me. After all of that, the request is officially dropped onto the cabling or the wireless network to the node on the right. Think of the 3 layers here as being the processes that data must undergo before being suitable for network transmission. Once the data has been sent to the right, all those same processes have to be undone before data is presented up to the web services on top to give you your web page. If these different layers are built with applications using the common standards defined in a network model, then even if these 2 nodes are built using different hardware and different protocols, they should still be able to interoperate. Think through the process of writing and sending a letter to a friend. You write the content of that letter, which no one is going to see except for you and the final recipient. You then take that letter, put it in an envelope, address it on the front of the envelope, and submit it through the postal system. The process of putting that letter in an envelope and addressing it is similar to what happens in the model we looked at in this lesson. You have to package the data you're trying to send and then put information on the front of that data to tell it where it has to go. All the different network devices in between you and your final recipient have to examine that address information and figure out the next step to get it closer until it eventually reaches its final destination.